Bismillahirrahmanirrahim. Dear students, today we will start kinematics. Kinematics is the branch of physics which deal with the study of motion. But in this branch of physics, we will not deal with forces. It means the causes of motion. We will only deal with the motion and different terms related to motion. This is lecture for grade pre0. This is physics lecture number 1 for O level. I'm Faradnan Khan, Bahria Town International Academy. In this lecture, there are some learning objectives and outcomes. Students will be able to know about motion of bodies. They will also be able to define distance and displacement and how to differentiate between these two. They will understand the concept of speed and velocity, and they will also know the definition of acceleration, its formula, and there is an example and numerical problem which we will solve. Now, the contents of this lecture is first of all we will deal with distance and displacement. What is the difference between distance and displacement? Secondly, we will deal with the major part of kinematics, which is velocity and speed. We will be able to differentiate between these two. What is the difference between these two and how these two are related to each other? You will know that magnitude-wise, speed and velocity both are the same term, but the only difference is that velocity is a vector quantity and speed is a scalar quantity. We will also discuss vector quantity as well as scalar quantities. The next part will be acceleration. This is very important topic. Acceleration we will understand, and we will discuss the types of acceleration: positive acceleration, negative acceleration, which is also known as negative acceleration, deceleration, and retardation. And then we will study some examples regarding acceleration. Next, just to introduce the O-level syllabus of physics, the first topic is about physical quantities and the introduction to these physical quantities. We will just differentiate these two quantities initially in terms of scalars and vectors. Now, what are the scalar quantities? Scalar quantities are those quantities which is magnitude and they don't have any direction. There are so many examples, just like length, mass, time, electric current, temperature, area, distance, speed, energy, density, power, and there are so many examples of scalar quantities. Now the next quantity is next type is vector quantities. Now those quantities which is magnitude as well as direction, magnitude and direction. So those quantities are known as vector quantities. These quantities, there are some examples just like displacement, velocity, force, acceleration, momentum, weight, impulse, and pressure, etc. So we will discuss all these because these are new for the students. They will step by step they will understand all these terms. They don't need to confuse at that time. So what is momentum and pressure, etc. You will study all these terms in the next few chapters. So vector quantities are those quantities which in magnitude and direction, and scalars are those quantities with magnitude but they don't have direction. So this is the main difference to understand, because these two terms in your syllabus, scalars and vectors, these terms will repeat. Now coming to the next slide. Now the basic thing in kinematics is to discuss distance and versus displacement. Now what is distance and displacement? Distance is scalar quantity and displacement is a vector quantity. This is why we study in introduction scalar and vector, because any quantity we'll study in future we will differentiate somehow between scalars and vectors, so students must understand these terms initially. For example, just going to definition, the total length of a path that an object travels, or simply we can say it is the actual path between 2 points. Just like you see in the figure, this is a starting point and finishing point. So the actual curve path, the dotted path, which is actual and curve path, it follows so many directions. So this path is known as distance, and the directed path from start to finish, the straight red line, is displacement. It is the straight line path between the object's origin and its final position. So it is directed distance. So displacement is somehow refer is directed distance as well. So this is basically the difference between distance and displacement. Now the main topic of kinematics is speed and velocity. Now speed, by definition, speed is defined as the rate of change of distance, or we can say speed is basically a measure which tell us that how quickly distance is traveled by a body. It is a scalar quantity. In its unit is meter per second. You see in this figure it is meters second inverse. It is not minus 1, it is second inverse, meter per second, or we can write by changing denominator to numerator. We can write it is meters per second. Formula is V is equal to d by t. This d represent distance and t represent time, and v is the symbol of velocity as well as for speed. It is shared by both. Now coming to the definition of velocity, velocity is defined as the rate of change of displacement. In case of speed, it is the rate of change of distance. In case of velocity, it is the rate of change of displacement. It is a vector quantity and both share the same unit, meter per second. The greater units are kilometers per hour, and the formula of velocity is uh, displacement divided by time. So v is equal to displacement divided by time. These are the approximately very important, we can say simply we can say this is very important topic of kinematics, because speed, velocity, speed time curve, velocity time graph, and distance time graph we will study in the next few lectures. So velocity, speed, and the next very important topic will be acceleration. But just let's see speed. Look at these two figures, these two cards. Speed, how fast you are traveling. Velocity is speed in the given direction. It is also we can say speed plus direction, it makes velocity. Means velocity is also how fast you are traveling in a specific direction. So speed is a quantity which is directionless quantity, scalar quantity, and velocity, if you express speed in a specific direction, it becomes velocity of a body. Now you can say the most important topic of this chapter kinematics is acceleration. It is the rate of change of velocity, or it is the rate at which an object increases speed or velocity. It can be increases, it can be decreases. Speed can increase or decrease. In both cases it is referred as, in broader term, it is referred as acceleration. So acceleration is change in velocity divided by time taken by a body. So it is acceleration of body. Velocity is measured in meters per second and time is measured in seconds. So acceleration is measured in meter per second, or we can simply say meter per second square. Now let's solve a numerical problem regarding acceleration. Just a very simple basic numerical, how to find out acceleration of a body in the given time if the initial and final velocities are given. Numericals can be of many types. In generally O levels, mostly we are looking for graphical analysis. We will do in the next lectures, but just to discuss the basic simple question, on the basis of which we want to discuss the formula and how to use this formula of acceleration. Now let's see. The question is, find the acceleration gained by the body in 5 seconds. if its initial velocity is 20 meters per second and final velocity is 40 meters per second. We have to find the acceleration. Now if you see the data given in this question, the time is given, which is 5 seconds. Initial velocity means the starting velocity of a body, it is 20 meters per second, and final velocity of a body, it is 40 meters per second. Now you see, first of all, we have to deduce the data from the given question. Let's see, initial velocity is denoted by u, which is 20 meters per second. The final velocity of a car is denoted by v, which is 40 meters per second, and time interval, which is denoted by smaller t, it is 5 seconds, and acceleration, it is denoted by, all you see, all the letters are in lower case. It is so the formula is acceleration is v minus u divided by time, or we can say acceleration is final velocity minus initial velocity divided by time. If you compare v and u in alphabetic order, the first letter comes in alphabetic order is u and then v. So u is initial velocity, which comes first, and v is final velocity, which is next. So final minus initial divided by time. If you put the value, so acceleration is 40 minus 20 divided by 5, it is 20 by the difference of speed is 20 meters per second divided by 5 seconds. So acceleration is 4 meters per second square. So acceleration of body is 4 meters. So this is very basic formula, with the help of which we can find the very basic and simple numerical. If velocity is changing and time interval is given, we can find out the acceleration of a body. So this is just simply the acceleration, a simple basic numeric. Now next, if you see the symbol figure is a drawing of a child. If you see it is a rolling ball which rolls down the slope. If you see, initially it is in rest. If you give initial push to this body, it will gain velocity. Velocity and speed of body will increase. So it is this ball is accelerating. It is positive acceleration. So what is positive acceleration? If the velocity of a body is increasing with time, if velocity of body is increasing with time, it is known as positive acceleration. For example, if a heavy steel ball is dropped from helicopter, very heavy steel ball is dropped from helicopter, if you see, it will continuously gain speed. So in this case, the body is gaining acceleration, is gaining speed, speed is changing, velocity is changing, because it is traveling in the same direction. So we will use the term velocity. So velocity of the ball is changing. So this is the example of a body which will have positive acceleration if we give the initial push, and it will start acceleration. So this is the example of positive acceleration. Let's see the example of negative acceleration. If a body is gaining height, it's moving up the slope, and you see, this is the example of a body, and the velocity of body will decrease with respect to time. So you see, this body have negative acceleration, because velocity of this body, velocity of this ball will decrease. So this is the example of negative acceleration. There are so many examples. If a driver applies brake to a car, moving car, if you see this velocity of a car will also decreases. So we will give some more examples. Student can find out a list of bodies having negative acceleration. So this is also students are required to search on internet, Google it, the examples of positive and negative acceleration. These are two basic examples of positive and negative acceleration. So in today's lecture, we discuss scalar quantity, vector quantity, distance and displacement, and somehow differentiate between these two. Then we switch to defining speed and velocity, Then we will discuss acceleration, the types of acceleration, positive acceleration, negative acceleration. Then we study a simple example how to solve a numerical of acceleration, how to use the formula of negative acceleration and positive acceleration, and then we give some example of positive acceleration and negative acceleration. Students can search out on internet. Now there is the first assignment. uh, the first assignment is this is assignment number 1. You have to write the answer of the following questions. This is just activity that what we want, that you should have some learning outcome from this lecture, and you should somehow understand and define a few terminologies from this given lecture, and there must be some output of this lecture. The first one is you have to define scalars and vector quantity. See, the choice of words are yours. You can copy, you can search out the definition on internet, and you may give you may define certain quantities using this lecture as well. You can use some slides, initial slides, to define scalars and vector quantity, and even you can differentiate and give example as well. The second question is you have to differentiate between distance and displacement. The given slides, there is a slide which differentiate between these two. You can draw a figure. You can also draw using Microsoft Word by plotting initial point and final point, and drawing a straight arrows from initial point to final point to show displacement. And you can draw a curved path from initial to final point to show distance of a body. So you can use these tools or any other tool, just like Microsoft Word or any other Paint, etc., to plot and give an example which differentiate between distance and displacement. And the final point is you have to differentiate between speed and velocity. You have to define it and give example, and secondly define velocity, give its units, and what is the difference between these two. So I hope you enjoy this lecture, and if you have any question, any queries, you're most welcome to ask. You can go to the Google Classroom and your respective class, which is O1, pre-0 physics class of Saradnan. You can type your question. You have my WhatsApp number. If you have any question, you can directly contact with your teacher. If you want to solve any question, if you are searching anything on internet regarding this lecture, and if you have any question, you are most welcome to ask question. And that's it for today, and thank you, and Allah Hafiz.